Good afternoon, everybody. Welcome to this session of Transportation Engineering. In the previous class, as I had explained you all about the importance of highway alignment. Basically, highway alignment is that center line which is marked onto the road so that the road is divided equally. But as the terrains are not flat everywhere, we come across horizontal curves as well as vertical curves and everywhere. So at some places where we come across horizontal curves, I had also told you all about the horizontal alignment also, how we need to maintain the alignment even when the road changes its direction also. Sometimes we have a flat terrain, so we get a flat road, and sometimes we need to take some curves also to avoid obstructions or other things coming in between. So at those places what happens is, if the terrain is slightly, if we are getting a horizontal curve, at those places what happens is we come across a curve. At that time we'll have to come up with a phenomena known as super elevation. This is a very important phenomena. We'll be seeing what is super elevation. I think I had explained you all in the previous sessions. So basically what happens when we come across, you can just see this. If this is the road and we have to connect to this road here, so this connection, this curve, so this is the horizontal curve. But what happens is, and this is your alignment, we'll be maintaining this alignment throughout. The center line will be maintaining throughout. So what happens is, when the vehicle is passing from this side, you can just see here, this is the vehicle is passing from this side. At this place, the vehicle will have to turn like this. But what happens here at the horizontal curve, what happens is, centrifugal force is generated here. Now, if we don't come up with a phenomena or don't come up with some measures where the centrifugal force should be reduced, if you don't reduce this centrifugal force, what happens is, this vehicle, it tends to move this side, and there are chances to move this side, and there are chances of overturning and skidding also. There are chances of overturning and skidding also. So this centrifugal force which is generated here, we have to come up with some measure where this centrifugal force can be reduced. Now what to do that? So what happens is, when we come across this horizontal curve, when, see, this is a straight alignment, straightly aligned, and we are connecting this horizontal curve. At this place what happens is, we have to come up with super elevation. Now what is that super elevation? We'll be seeing that now, and how to design super elevation and what are the equations involved in super elevation. We'll be seeing that here now. Let us check that what is this super elevation. In the previous session, I had explained you all what is super elevation. Basically, super elevation is that if this is your inner edge and this is your, let me just explain you like this, and this is the curve. This is the curve. At this curve, what happens is, this curve, if this is your bottom line, inner edge, and this is your outer edge. Okay, you can see here, no, this is our alignment which has to be maintained throughout. What do? Is we just raise this part of the pavement. Inner out, we maintain this as this is a triangle. We just raise this part of the outer pavement. Because of that equilibrium is maintained and the centrifugal force is reduced, and in turn to that, the vehicle cannot be overskidded or the vehicle will not be overturned. So how to lift this? What is this angle? This angle theta, or it is equal. Super elevation is also denoted by small e. Now what is this angle? How we'll have to lift this? How much amount of degrees we'll have to lift this? This is called as super elevation. We'll see that equation completely here. You must have understood increasing the pavement from the outer edge, maintaining this is inner edge, this is the inner edge, just raising this pavement at the outer edge to a degree, to some angle, that is called as super elevation. Now this is, why is this maintained? So that the centrifugal force which is created because of the vehicle, it can be reduced, and in turn if we reduce that centrifugal force, that will reduce the chances of overturning and chances of skidding also. So this is called a super elevation. I will once again write down what does super elevation mean, and today we will be seeing the design of super elevation, what is the concept and what are the equations involved in the super elevation. We will be seeing that here now. So you must have understood what is super elevation. Basically super elevation is the increase of the outer edge of the pavement with respect to the inner edge to counteract the centrifugal force, which will reduce the chances of overturning and skidding. Now today we will be seeing how will that work out. We will be just seeing, let us see here, this is our vehicle. Okay, let us take this angle as theta. This is your inner edge and this is your outer edge. Okay, now what are the forces acting here? We will be seeing those forces over here. First we have this W, that is the weight of the vehicle. Okay, now exactly perpendicular to this we have this P. This is the centrifugal force that is acting here. We have this W, weight of the vehicle, that is acting downwards. We have P, that is the centrifugal force that is acting in this way, Basically I had told you the vehicle when it turns at the corner, at the horizontal curve. This is the centrifugal force that is generated here. So we'll have to see what all are the other forces. We have one frictional force also here. Friction is also caused here. Let us resolve this forces P and W. As you know, we have to resolve these forces into forces in the x direction as well as forces in the y direction. We'll resolve these forces in the x direction and we'll resolve these forces in the y direction. Let us see that now. Let us resolve these forces here. P, you can see here, if this is the angle theta formed with the vertical. If it is with the horizontal, if it is with the y axis, you know how will it get resolved into forces, and if this force is with the x axis, how will it get resolved? Let us see here. I am just resolving this force P. As you know, this will be P cos theta. And this force which act downward, this will be P sin theta. Okay, you must have learned this in your mechanics subject. This force P is being resolved into force in the x direction and force in the y direction. I am just resolving this force P in x direction, that is P cos theta. Basically this angle is being formed with the x axis, and this downward, you know, this is getting in P sin theta. Same way I'll resolve this force W also into x and y direction. You can see here this force W x sin theta. Now don't get confused here. How did I write in x direction? Why am I getting W sin theta? You can see this angle is being formed with the y axis. As you know, if the angle is formed with the x axis, in the x direction you will get P cos theta, and in the y direction you will get P sin theta. If this angle is forming with the y axis, this will change to W sin theta, and in this direction again you will have a load in this direction also, you will get here also, that will be W cos theta. So basically you have two forces acting in this direction downwards, that is W cos theta from the weight of the vehicle and P sin theta from the centrifugal force of the vehicle. I am adding it here, and in the x direction you can see W sin theta because of weight of the vehicle and P cos theta because of centrifugal force coming here. Hope you have understood till here. It is very simple. We are taking this as the inner edge. We are just raising this pavement here. We are raising this. Basically we want to know how much amount we will have to raise the pavement from the outer edge. So what we are telling, this is the vehicle, You just see what are the forces acting here. W is the weight of the vehicle that is acting downward. P is the centrifugal force. Okay, F is the frictional force, and we are resolving this W and P into forces in X and Y direction. P is the force in X direction, it is P cos theta, and in the Y direction it is P sin theta. W again I am resolving it. In the X direction it is W sin theta, and in Y direction it is W cos theta. Okay, now frictional force, let us write here what is it. W is equal to weight of the vehicle and P is the centrifugal force F is the frictional force. Now what is F? F is the frictional force. F will be mu into N. N is the normal reaction. N is the normal reaction. As you know, N will be normal reaction. It will act directly downward. That is W cos theta plus sin theta. Mu you can also write it as F. F into N is, remember N is W cos theta plus P sin theta, as normal will act directly downwards to the vehicle. So F into W cos theta plus P sin theta. You can see here, this is F, this is the frictional force that is being generated. Friction is also being generated here. As the centrifugal force is acting that way, friction will act in the opposite direction. You must have learned all this in your previous subject of mechanics, as you can see. You can see here, F, as I have told you, F is the frictional force, that is mu is F into W cos theta plus P sin theta. Now what all we have, let us resolve all this. As you know, conditions of equilibrium. What are the conditions of equilibrium? We have three conditions of equilibrium. That is sigma x is equal to 0, sigma y is equal to 0, and sigma m is equal to 0. So what is sigma x is? These are the three equations of equilibrium. Sigma x is, we will be seeing all the forces that is acting in the x direction. In sigma y we will be seeing all the forces that is acting in the y direction, and sigma m is the moment that will be acting here. So let us see now at sigma x what are the forces acting in the x direction. Let us see here, sigma x is equal to 0. What all forces are acting in the x direction? Let us see that here. You can see here, we have this force coming here, P cos theta. We have P cos theta here, P cos theta. Okay, that is acting at the right, in the right direction, so I have written it one side. Other directions, other forces acting is W sin theta, and this is the frictional force that is acting here. So let us write, that is why I am taking that at the other side, that is W sin theta plus, you have seen frictional force F here. Now what is F? F is mu into the normal reaction. Mu I am writing it as F into W cos theta plus P sin theta. F into W cos theta plus P sin theta. Okay, hope this is clear till here. It is very simple. I am taking all the forces in the x direction. P cos theta is acting at the right side, and W sin theta is acting at the left direction, and frictional force also we are getting it. I have just substituted those values here. We can see here. Let us see this, W sin theta plus F W cos theta plus F P sin theta. Okay, it is very simple. Let us take all the terms of P to one side and W to one side. Let us take all those terms here. P cos theta minus of F P sin theta is equal to W sin theta plus F W cos theta. Let us take P as common here. P is common, cos theta minus F sin theta is equal to W into sin theta plus F cos theta. I have just taken all the terms of P to one side and all the terms of W to one side. I have taken P as common. I am getting cos theta minus F sin theta. Here W as common, sin theta plus F cos theta. I will just change the terms here, P by W. I have got W this side, I am be taking these terms that side. So it will be sin theta plus F cos theta by cos theta minus F sin theta. You can see here P by W is equal to sin theta plus F cos theta by cos theta minus F sin theta. You can just check this here. Till here I hope this is clear. Okay, P by W is equal to sin theta plus F cos theta by cos theta minus F sin theta. Now this P by W is called as centrifugal ratio. Remember this is called as centrifugal ratio. I am just marking this as 1. Okay, I am marking this as 1. Let us see further. Let us make it more simple. Let us see. We will make it more simple. As you know, centrifugal force P, as we know, P is the centrifugal force, that is mv square by r. Okay, m. Now what is m? M is the mass of the vehicle, v is the velocity of the vehicle, and r is the radius of curvature. You can just see it here. M is the mass of the vehicle. Okay, v is the velocity of the vehicle, and r is the radius of curvature. V is velocity of vehicle, and r is radius of curvature. Okay, P is the centrifugal force, that is mv square by r. Now let us see here, mv square by r. I will be multiplying and dividing g here. Let us see this, g by g. I am multiplying g, okay, acceleration due to gravity, g at the top and at the bottom. So this will become P is equal to mg v square by gr. As you know, what is mg? Mass. So as you know, this P is the centrifugal force, mg v square by gr. We know mass into gravity, that is W. mg is equal to W. I'll just substitute it here. So this will become P is equal to W v square by gr. I'll just take this W this side, so it will be P by W is equal to v square by gr. Okay, now we have got the value of P by W as v square by gr. As you know, we have got this from the first equation. P by W is equal to sin theta plus F cos theta by cos theta minus F sin theta. I'll substitute this value of P by W of v square by gr here, and let us see what is the equation we'll be getting it as. So v square by gr is equal to sin theta plus F cos theta by cos theta minus F sin theta. Hope you have understood till here. It is very simple. I have just calculated this. I have just simplified it. P is equal to W v square by gr. I have taken this W this side. So P by W is equal to v square by gr. This I have substituted in this equation of equation 1 what we have got. V square by gr is equal to sin theta plus F cos theta by cos theta minus F sin theta. Let us simplify it more. I will just simplify it more further. You can just see here. We'll have to simplify it more, then finally we'll get the equation for super elevation. See, what is it? V square by gr is equal to sin theta plus F cos theta by cos theta minus F sin theta. Okay, I'll just divide this whole equation by cos theta. I'll divide this part also and this part also by cos theta. Let us see what we'll get that as. V square by gr is equal to sin theta by cos theta plus F cos theta by cos theta divided by cos theta by cos theta minus of F sin theta by cos theta. All of you all know sin theta by cos theta is tan theta. So this will become as V square by gr is equal to tan theta plus f cos theta, and cos theta will get cancelled, this and this will get cancelled, tan theta plus f by 1 minus f tan theta. Hope this is clear till here. It is very simple. We have just substituted this value of P by W in this equation, that is V square by GR, sin theta plus F cos theta by cos theta minus F sin theta. Okay, then after this what I have done, I have just divided this whole equation by cos theta. I have just divided, this gets cancelled, and this has become V square by GR is equal to tan theta plus F by 1 minus F tan theta. We'll have to simplify it more. We'll just simplify it again. Simplify it just more. So what we'll do is we'll take tan theta is equal to E. Let us, this is angle of super elevation. This is the angle of super elevation theta. We'll just take it as tan theta is equal to E. This is the angle of super elevation. This is the angle of super elevation. This is what we want to know. What angle should it be? How much should we lift the outer edge of the pavement? That is what we are seeing here. Tan theta is equal to F. I'll just substitute it here. So it will become B square by GR is equal to E plus F by 1 minus FE. Okay, fine. V square by GR is equal to E plus F by 1 minus FE. I have just substituted. I am taking tan theta, that is angle of super elevation, as E, and that is I am just substituting here. V square by GR is equal to E plus F by 1 minus FE. Here let us simplify it more. Let us just simplify it more. Let us take it more further. We have got it as V square by GR is equal to E plus F by 1 minus EF, you can take it as. Now what is E? E is angle of super elevation, F is the friction, what we have got. Now let us see what will be the angle of super elevation and what. Let us simplify it more. Now F is the frictional force, as this is the lateral friction. See here, as the vehicle is moving outside, this friction that is being caused, this is the lateral friction. That you should understand this very well here. You can just imagine here, the vehicle is moving on the horizontal curve. There is a curve, and as the vehicle is moving that side, the friction that is caused is, that is the lateral friction. Now the maximum lateral friction that is caused is, that is F max. We have a value for that, that is 0.15. This is the maximum lateral friction that we get. For a lateral friction we get this value of 0.15. This is F max. Now what is now the angle of super elevation for plane and rolling terrain? The maximum angle of super elevation for plane and rolling terrain, it has been given as, the value is given as E max is 0.07. This is the maximum value for the super elevation for plane and rolling terrain. We'll just substitute these values and we'll simplify this equation more, so that we'll see what we'll get. I'll just substitute the values in this. 1 minus EF, what will it be? 1 minus of E is 0.07 into 0.15. If you calculate this value will be approximately 1. This value will be approximately 1. So that will become 1 minus 1. This will be 0. So this value 1 minus 1, this will become 0. So the final equation what we will get for super elevation, that will be E plus F is equal to V square by G into R. This is the final equation that we are getting for super elevation, where E is the super elevation, F is the frictional force, V is the velocity of the vehicle, G is acceleration due to gravity, and R is radius of curvature. This is very important. Super elevation is very important. Always remember, whenever we come across a horizontal curve where the vehicle needs to take curve, at that place what we do is we slightly increase the outer edge of the pavement. That increasing of the outer edge of the pavement is called as super elevation, and that has been given by this equation. E plus F is equal to V square by GR, where E is the super elevation, F is the frictional force, V is the velocity of the vehicle, G is acceleration due to gravity, and R is the radius of curvature. So this is very important. I request all of you all to please go through this, because this is a very important concept, and you will get problems on this also. So this is the expression for super elevation, is expression for super elevation. This is a very important concept and you have problems also related to it. So E plus F is equal to V square by GR. You have one more concept also related to it, that is called as equilibrium equation, equilibrium super elevation. We'll be seeing that also, and thereby in the next class we'll be seeing a problem also related to it. I hope this concept is very clear with you all. You all have to go through these equations as this is very necessary. See, I'll just give you a small recap. This is very simple. This is a vehicle moving, that is moving in the vertical direction, and suddenly it has come across a horizontal curve. Now what happens in the horizontal curve? What we are trying to do is, we are just trying to increase this pavement, slightly raising this pavement from the outer edge. So what happens here? What we are seeing is, what are the forces coming here? This is the centrifugal force that is acting in this direction. W is the weight of the vehicle which is acting downwards. We have F, that is the frictional force that is acting against this friction, against this centrifugal force. Now what I have done is, I have just resolved this forces into other component, that is in the x and the y direction. P force has been resolved into P cos theta, that is in the x direction, and P sin theta, this is in the y direction. Okay, fine. Now I am resolving the W force, that is the weight of the vehicle, also in x and y components, that is W sin theta and W cos theta. You don't get confused here why I am taking this as W sin theta, as this is making an angle with the y axis. When any force makes angle with the x axis, the x component will be whatever it is into cos theta, and if it is making angle with the y axis, then it will make W sin theta. This is W cos theta. Okay, now what I have done after that, I have just resolved these forces. Equations of equilibrium, you know, that is sigma x is equal to 0, sigma y is equal to 0, and sigma m is equal to 0. What I had done, I had taken sigma x is equal to 0, and I have computed all the forces that are acting in the x direction. So in the x direction I have P cos theta, that is acting at the right. In the left side I have W sin theta and the frictional force. Now what is frictional force? F is equal to mu into a normal reaction. Normal acts directly downward. In the downward we have these two forces, that is W cos theta plus P sin theta. So F is equal to, mu can be written as small f also, F into N, that is N is W cos theta plus P sin theta. Then what I have done, I have just resolved all the forces in the x direction, that is P cos theta is equal to W sin theta plus F into W cos theta P sin theta. Okay, this is clear till here. Now what I have done, I have taken all the forces of P to the one side and W to the one side. I have taken P common and W common. After that I have got an equation of P by W is equal to sin theta, some equation I have got. Now what, to make it more simple, what I have done, P is the centrifugal force which is being given, we know that it is being given by mv square by r. Mv square by centrifugal force P is mv square by r. Then what I have done, I have just multiplied gravity G at the top and at the bottom. As you know, mg is W, mass into gravity is the weight. So I have just substituted that mg by W, that has become Wv square by gr. I have taken W to the other side, that is behind, that is bottom of P. So P by W is equal to V square by gr. I have just substituted that value of P by W in the equation 1 which I had got previously. So V square by gr is equal to sin theta plus F cos theta by cos theta minus F sin theta. Then I have divided cos theta at both the sides of the equation. Then I have got, you can see here, V square by gr is equal to sin theta plus F cos theta by cos theta minus F sin theta. I have just divided by cos theta on both this on this side. I have got it as this gets cancelled, cos theta. I have got this equation, tan theta plus F is equal to 1 minus F tan theta. Now I am taking tan theta as 1, as this is the angle of super elevation, that is E. I am just substituting it here, E plus F by 1 minus Fe. Okay, let us simplify it more further. What I had told you, E is the angle of super elevation and F is the frictional force. Frictional force has been given as it is a lateral friction. It has been given as the maximum frictional force is 0.15. Okay, 0.15, and E, the maximum super elevation E is 0.07. I have just substituted those values in this equation and this has become 0. So final expression for super elevation, what I am getting it as, E plus S is E plus F is equal to V square by GR. Hope this is clear till here. This session is very clear to you all. I request all of you all to go through this expression, because sometimes he might even ask you how did you get the super elevation or the equation for super elevation. You will have to prove it in this way. I request all of you all to please go through this session. For any comments, please comment in the comment box. Thank you for this session.